Hello viewers, in this video we'll be solving these particular questions. We have about three questions here. This is question number one, question number two, it's an exponential equation. Then question number three, it's a logarithmic equation. Where is the equation? This is the equation. Then number four, it's a circular motion. So let's start. Now, this one, we want to evaluate this logarithm in terms of x and y. So this is what we have. We have log half is equals to x, which we can write as what? We can write it as log 2 to power minus 1 equals to x. So minus 1 can go down. So we have minus log 2, it's equals to x. And this implies that log 2, it's what? It's minus x. So we have this and we have this. Now, this is log to base 6 of 27 over 16. And this is, the denominator is log to base 6 of 10 to the power minus 1. We can write this as what? We can write this as just log to base 10 minus 1 of what? 27 over 16. Where is this coming from? Remember, if you have log to base a of b, we can write it as what? Now, let's say log to base a of x is the same thing as log to base b of x over log to base b of a, right? So if you have this, so we have this side, so we can also write it as log to base a of x. So this part here is equivalent to this side. If you take b to be 6, right? And you take x to be 27 over 16, and you take a to be 10 to the power minus 1, then we can write it as this one, which is log to base 10 to the power minus 1, then log to base 27 over 6. Okay, so now let's move from here. And this is going to be what? This minus 1 can also come down here because this is minus. So this will be just minus log of what? To base 10 of 27 over 16, right? Now this minus, we can take it up so that we just have log to base what? To base 10 of 27 over 16 to power minus 1. And now this we can write as log to base 10. This will just become the reciprocal 16 over 27, which we can write as, this is log to base 10. We can forget about writing the base, just write log. So this is log 16 minus log 27. And this is log 2 to power 4 minus log 3 to power 3. So we can bring 4 down. So we have 4 log 2 minus 3 log 3. But what is log 2? Log 2 you can see is minus x. So this is just 4 times minus x minus 3 times log 3 is y. So we're done. So we'll have minus 4x minus 3y. That is the answer in terms of x and y. Now, number two. Number two is an exponential equation. If you look at this carefully, we can rearrange this and write it as this. Minus, what we have here is nothing but 5 to power x times what? 5 to power minus 1 is equals to 4, right? And with this, we can decide to multiply. Maybe we can multiply through by 5 to power x. So we can multiply just by 5 to power x. So here will become 5 to power x times 5 to power x minus, this will be 1 to power 5x times 5 to power minus 1 times 5 to power x. And the right hand side also will be 4 times 5 to power x. Now this will become 5 to power 2x minus this 5x will go with this 5x. And this is 5 to power minus 1. We can take it up so that it becomes just 5. And this, we still have this one here. So we can collect like times, bring everything together here. We can write this first. This will be minus 4 times 5 to power x, then minus 5, it's equals to 0. Here we can make a substitution. So what kind of substitution can we do? We can let u to be equals to maybe 5 to power x. And if you do that, you will realize that this problem will be transformed towards u square minus 4u minus 5, it's equals to 0. So we have a quadratic equation. And if we factorize this, this will give us u plus 1 and u minus 5 all equals to 0. And so what does that mean? Let's finish it here. It means that u is equals to minus 1 or u is equals to 5. Now, what is u? U is 5x, so you have 5 to power x is equals to minus 1, or 5 to power x is equals to 5. Here, clearly, there will be no answer, because if you try to, okay, let's say you take log to base 5 of both sides, right? You have log to base 5 of minus 1. This will give us x. So you have x is log to base 5 of minus 1. This is impossible because you can't take the logarithm of a negative number. So the only one here, but this part, this is 5x. You can write this as 5 to power 0. So it means that x is going to be just x is just going to be 0, right? No, sorry, 5 to power 1, I mean. This is 5 to power 1. So this is x is equals to 1. Now, x equals to 1 is the solution of this problem. X equals to log. Here, you cannot take the log of a negative number. So remember we said x here is log to base 5 of minus 1, which is impossible. So we have just one solution. All right, for number 3, we want to find the sum of solution of this logarithmic equation. And this is the equation here. So here, what can we do? First of all, we know something. We know that one of the laws of logarithm, if you have log to base a of b, is the same thing as 1 over log to base b of a. So it means that this, since you have 1 over this, you can write here, you can interchange. So the base here will become 2, while here you will have x minus 2. So this and this, just the same thing. Then plus, now this we can write as log. This is 4. And here you can see we have 2 already. So our target will be to make all the base 2, all the bases to be 2. So you can write it as 2 to power 2 x minus 4. And here you can write half. And what can we do? This is 3. We can write this as 3 log to base 2 of 2. It's not a problem. Log to base 2 of 2 is 1. Then plus, here we have log to base 2 of 3. Now this we can write as log to base 2. This is x minus 2 to power what? To power half. And now this is 2 to power 2. So this will become 1 over 2 log of x minus 4. Now what have I used? One of the laws of logarithm is that if you have log to the base of a to power k of x is nothing but 1 over x log of what? Ax. So our k here is 2, so that's why we have 1 over 2. Okay, and now this we still have half here and brackets. Here we can write it as log to base 2 of 2 to power 3 and log to base 2 of 3. So what can we do? you can see that this half can come down here. So you have 1 over 2 log 2 of x minus 2 plus 1 over 2 log of x minus 4 is nothing but 1 over 2. Here becomes log to the base 2 of 8, and this is log to the base 2 of 3. Now you can see this, you see there is half here and there is half here. So we can actually take 1 over 2 as a common factor and just put a bracket here and put a bracket here, right? Then we can remove this half from here. But if you look this, since there is half here and there is half outside, we can what? We can cancel this half and this half, just like multiplying both sides by 2. So we are left with just this one here. And since this is addition, we can change it to multiplication to become log to base 2 of x minus 2 times x minus 4. And this is going to be, here we can write it as log to base 2. Also, we can write it as 8 times 3. Now we have the same basis on both, on the left hand side and the right hand side. We can drop the basis and just go with x minus 2, x minus 4 equals to what? 8 times 3, which is 24. And this is nothing but a quadratic equation. This will become, if you multiply these two, we will have x squared, think minus 6x plus what? 8 is equals to 24. And this we can write as x squared minus 6x. So you bring minus 24 here, so uh, you have minus 16, right? Equals to 0. And we can factorize this as x minus 8 and x plus 2 equals to 0. So from here we can get the values of x. So clearly we have x equals to what? 8, or x is equals to what? Minus 2. But this is a logarithmic equation, so we need to check our answers because we know that the base, the domain cannot be negative, right? So let's check now. Let's do the checking here. Say we want to check. So now we check. Still black. Let me get some. Okay. So let's check with when x is equals to what? When x is minus 2 and c. Now you can come here. You can check here because this is it's still the same. If you look at the first term there, this term is log to base 2 of root x minus 2. Now, if you put x is equals to 2, you will have log to base 2 of what? Root of minus 4. Now, this is already a bad news because you cannot take root of minus 4. It's a what? It's a complex number, right? Okay, since it's a complex number, you cannot take the logarithm of a complex number. So this is impossible. So it means we have to what? We have to reject this one. Yes. But if you try x is equals to 8, x equals to 8 is going to work because here you will have 8 minus 2, which is root of 6 is a positive number. Now, if you try 8 here into this term, you will have log to base. Here will be 8 minus 4, which is 4, which is also a positive number. So the right solution is this one. This one we have to reject it because it failed to satisfy one of the term. One of the term here will fail. So, and we're asked to look for what? We're asked to look for the sum of solution. In this case, our solution set has only one answer, which is what? Which is 8. So the sum is still going to be what? It's still going to be 8. Okay, so let's go to this circular motion. Now we have a tire of a bicycle with radius. So this is the radius of the tire, which is given to be 26 meters. And what else do we have? This tire is rotating at the rate of 250 revolution per minute. So this is our angular speed, which is just what? 250 rev per minute. And what does the question want? The question wants us to find what? To find the angular speed, but now in rad per hour. So this is just a matter of conversion. This is the angular speed. Initially, it's giving us 20 rev per minute. So we just need to convert it to radian first by multiplying by 2 rad divided by 1 revolution, because we know that what? 1 revolution is the same thing as 2 pi rad. Okay. Now, but we have per minute here, and the question wants us to find it rad per hour. So if you look carefully, we need to also convert what? This minute to per hour. So to do that, we know that 60 minutes is going to give us what? 1 hour. All right. So I think now we are fine. And you can see that what? This minute will go with this minute, because 60 minutes make 1 hour. This revolution will go with this revolution. So we have just what? 250 times 2, which is 500 pi times what? We still have 60 here. So this is just going to be 60 rad. Then in the denominator, we only have hour left. So this will just give us 33 zeros, right? Pi rad per hour. So this is our angular speed. Okay. Then the next question says we should find the what? The speed, which is like the linear speed actually. The linear speed. So that will be what? V is equals to what? R omega. And what is R? We already know what is R, but R was given in meters, and we need it in kilometer per hour. So this is going to be 26, but remember this 26 is in meters, and we're given a conversion factor that 1 kilometer is 10 to power 3 meters. So what does that mean? It means we have to multiply this by what? 1 kilometer, which is equivalent to 10 to power 3 meters. Okay. So now this is for the conversion. Then multiply by W, which is our angular speed, is already known, which we know from the first part, which is 30,000 pi rad per hour, right? Okay. Now, if we do this calculation carefully, we will see that what we have, this is 3 zeros. So 3 zeros will go from here. We'll go with this one. So we'll have 26 times what? 30 pi. Yep. Then what is left is kilometer per what? Per hour. So we'll have 780 pi kilometer per hour. Okay. All right. So I think that's the end of this solution to these quiz problems. So these problems are from 4.4 to 5.1. That's exponential equation, logarithmic equation, and also circular motion. I hope everything is clear. If you have a question, just put it in the comment section. Thank you for watching.